Welcome to the Solving Equations podcast, brought to you by the Enrichment Division of White Lake Area Community Education. The purpose of this podcast is to provide supplemental instruction as a service to students and parents.
Hi, I'm Al Caraba. This is part 2 of 3 parts of Solving Equations. This section is entitled Solving Equations Using Multiplication or Division. Let's get started. Just a reminder that in solving equations, again, we want to remember our 2 basic rules here. We are undoing what has been done to our variable, and we want to make sure we do the same thing to both sides. Again, remembering that an equation or an equal sign is like our seesaw or teeter-totter. As long as we keep things balanced, everything is good. Let's look at this example here. In this particular example, we have 3 times some number x is equal to 27. Again, a relatively easy example because we know that 3 times 9 is equal to 27. But in combining this with some other more difficult problems and learning how to solve this correctly will allow you to solve many more complicated problems. Again, our first rule, undo what has been done. Our variable x has been multiplied by 3. And in order to solve this, undo the multiplication, we're going to divide by 3. So I will take my left side and divide it by 3. Remembering our rule number 2, which is to do the same things to both sides, we need to also divide by 3 on the other side. Notice that I'm not writing a division sign in here. I'm simply writing it as a fraction. And as we know, fractions are just division problems. Numerator divided by denominator. In solving this then, we see that the 3 divided by 3 becomes 1, or gives us an answer of 1, or 1 times x, because our variable still remains. Since we understand that a variable with no coefficient or no number in front of it has the 1, we can simply bring that down as x. Our equal sign comes down, and then simply 27 divided by 3. And 27 divided by 3 is 9. X is equal to 9. We can check our answer. Does 3 times our 9, which we're replacing x with, equal 27? Spell it correctly. Yes. So really kind of an easy example there using undoing the multiplication. Our second example here has a division problem. Although it looks like a fraction, which it is, x over 6, this really signifies that the x is being divided by 6, which is what a fraction is, numerator divided by denominator. Going back to our 2 rules, let's undo what has been done. Since our variable is being divided by 6, we'll undo that by multiplying by 6. So I will multiply that by 6. Remembering rule 2, doing the same thing to both sides, I need to also multiply the other side by 6. Again, we'll put our 6 in parentheses just as a reminder mathematically that we're multiplying and not adding or subtracting. If you look then, the 6 in the numerator and the 6 in the denominator will divide out and give us that 1 that we were talking about earlier. So all we're left with then on the left side of our equation is x. Working on the other side then, 5 times 6 is equal to 30. X equals 30 is our answer. If we go back and check our answer, is 30 over 6 equal to 5? And the answer is yes. And I even spelled yes correctly this time. Okay? 30 divided by 6 equals 5. If you look at a problem like this, and this is where we start to get into things that are more complicated, but still the same basic rules that we've done. We have a fraction, 2/3, that's being multiplied by our variable x, and that's equal to 16. Using our rule, undoing what has been done, we would say we're multiplying x by 2/3. So to undo multiplication, we would do division. And we would divide this side by 2/3. Must do the same thing to both sides. We would divide this side also by 2/3. Now I don't know about you, but this is kind of an ugly algebraic mess here, and something that's not extremely easy to do. So let's look at a way we can handle this fraction easier than dividing both sides by 2/3, which is correct and which will work. If we think of the 2/3 as the 2 being multiplied by our variable x and the 3 being divided by, we can simply undo our multiplication by division and undo our division by multiplication, which means anytime there's a fraction in front of our variable, to undo that fraction, all we need to do is multiply by our reciprocal, which is just the numerator and the denominator changing places. So to undo the multiplying by 2/3, we will multiply by 3/2. Rule 2, do the same thing to both sides. So I need to also multiply this side by 3/2. The 3's and the 2's will divide out, giving me what I want, which is the x by itself, which is the goal of equation solving. And now I need to multiply the 16 by the 3/2. We've done several problems like this in the past. Some people will use a calculator at this point. I think the easiest way to do this is to simply look at it as this. Since I have 16 in the numerator and 2 in the denominator, 16 divided by 2 will equal 8. So the 16 and the 2 will reduce out and just become 8. 8 times the 3 then is 24. A lot of different ways to solve that. You can figure that on your own. Not necessarily in this lesson are we going to talk about the mechanics of solving that every time. Let's check to see if our answer is right. 2/3 times our answer, which is 24, should equal 16. Well, 24 divided by 3 is 8, and 2 times 8 is 16. So the answer is yes, and I spelled it correctly again. As you can see, the problems will get more complicated as we go along, but if you follow the simple 2 rules there, you will find that you will have great success here in solving equations.
Thank you for watching the Solving Equations podcast, brought to you by the Enrichment Division of White Lake Area Community Education. We want your feedback. Let us know what you like or dislike about this series. Do you have a suggestion for a future episode? Please send your comments to Brian Barber at whitehall.k12.mi.us.